Hello everyone, welcome to my YouTube channel. Remember to subscribe and like my channel. So today I'm going to discuss about Solvay process. And Solvay process is the manufacture of sodium carbonate as a product and calcium chloride as a product. So sodium carbonate has many uses in our daily activities, and some of the uses of sodium carbonate is for the manufacture of soaps in saponification, manufacture of detergents. Detergents and soaps are the same. The difference between soaps and detergents is that one is a solid and another one is a semi-solid, in powder form. So detergents are always in powder form and soaps are in solid form. And another one is also used in the manufacture of paper. And it's also used in the manufacture of sodium silicate, which is a water glass, and also it is used in the manufacture of water softener, the pH modifier, and it's also used in swimming pool. Sodium carbonate is also used in removing stains from metals that are rusted. It's also used to remove stains. And also we have sodium hydrogen carbonate, which is also a product from the Solvay process. That sodium hydrogen carbonate is used in bakeries. That one is a baking powder. Sodium hydrogen carbonate is used as a baking powder. So it is used to raise dough. It is baking powder and is used to raise dough in baking. So that is another product from Solvay process, and it's also used in daily to daily activities. Another product is calcium chloride. This calcium chloride is used in toothpaste, and manufacture of toothpaste, we also need calcium chloride for healthy teeth. And also the Solvay process is termed as most economical because most of its raw materials are recycled back. Once the raw materials are recycled back, it means it can be used again and again and again in one of the cycles. So brine, the brine and ammonia. So ammonia here and water, and ammonia and water, those are the mostly recycled products in the Solvay process. So here the raw materials for the Solvay process, there is brine, which is concentrated sodium chloride, which sodium chloride is always table salt, but yet when it is in concentration form, very concentrated, it's called brine. And there is also ammonia. So ammonia is another raw material required. There is also water. Water is another raw material required. And there is also limestone, which is calcium carbonate. We shall get its use when we explain it. And there is also calcium carbonate, ammonia and brine. So the recycled product here mostly are water and ammonia, even if most of its raw materials are easily available apart from the ammonia, because water is a universal solvent which is readily available, and table salt is readily available. It can be gotten from the sea and taken to be concentrated to get brine. So on the first reaction here, the chamber here, brine, which is concentrated sodium chloride, here concentrated sodium chloride is mixed with ammonia, here concentrated ammonia. So that is the first reaction, concentrated brine with concentrated ammonia. They get when they are reacted, you'll get ammonico brine. So here ammonico brine is taken to the carbonating tower. Ammonico brine is concentration of sodium chloride with ammonia. It has no formula, but I'll just use this one to explain. So ammonico brine is taken to the carbonating tower. By the name carbonating tower, we mean carbonating, adding carbon. So here we'll be adding CO2 to the reaction. So, and where is that CO2 found? That CO2 is gotten from the lime kiln. So here the lime kiln is is the limestone is taken to the lime kiln. Limestone is calcium carbonate, and it's always white in color. So this calcium carbonate is taken to the lime kiln, and lime kiln, by kiln means there's a lot of heat applied on that site. So the lime kiln here, the calcium carbonate is heated. So here there is heat and this is the equation. So calcium carbonate is heated to produce calcium oxide with CO2. CO2 is carbon 2 oxide or carbon dioxide or CO2. You can call it CO2. So here the kiln, there is heating of calcium carbonate, and this calcium carbonate will need CO2 to take it to the carbonating tower. So this CO2 is reacted with ammonium brine. So reaction between ammonium brine and CO2. So here we have left the calcium carbonate on this side, and we have taken the CO2 on the carbonating tower. So reaction between sodium chloride, ammonia, and CO2 plus water. So here ammonia has the higher affinity to react with water. So you'll get ammonium, so here ammonia will react here. Ammonia will react with water, produce ammonium, will produce ammonium hydroxide here. So ammonia has a high affinity of water, so ammonia will react with water to produce ammonium hydroxide. Then sodium will react with water and the CO2. So here ammonium will react to produce ammonium hydroxide. So ammonium hydroxide is reacted with CO2 to produce ammonium carbonate. So ammonium carbonate and water, they are reacted in this experiment. So here the product will be ammonium chloride with sodium hydrogen carbonate, because ammonia reacted with water for the first experiment to produce ammonium hydroxide, and this ammonium hydroxide reacted with CO2 to produce ammonium hydrogen carbonate plus H2O, and this H2O is reacted with this H2O ammonium and with sodium chloride. They will be exchanged. So here it will be will be ammonium chloride here with sodium hydrogen carbonate. So ammonium chloride with sodium hydrogen carbonate. So after reacting and getting those two, so we have here ammonium chloride with sodium hydrogen carbonate, and this one is a solid and this one is a liquid. So that after obtaining these two compounds, you take it to the filter paper, you take it to the filtration. So here there will be filtration. The filtration will take place here between these two, and you know when filtration takes place between the solid and the liquid. So let me draw this way. This one is a filter paper here, and here you pour your liquid to this point. You pour your liquid to that point, that way. You pour your liquid that way. So when you pour your liquid and your liquid takes to this point, you'll call it a filtrate. But when it remains on the filter paper, it will be called a residue. So residue will remain on the filter paper, and filtrate will pass through the filter paper to the other container. So here it is the same thing. Ammonium chloride will remain on the filter paper, but sodium hydrogen carbonate will pass through the filter. So here we'll obtain sodium hydrogen carbonate. So sodium hydrogen carbonate will be taken to this place, and here we have the ammonium chloride. So ammonium chloride will still take it to the other side and react it with calcium hydroxide. So calcium hydroxide calcium hydroxide reacted with ammonia here. Ammonium chloride reacted with calcium hydroxide, you produce ammonia. This ammonia, it is taken back to generate more, to continue away the cycle in the Solvay process. And this calcium chloride is taken away as the byproduct. And this calcium chloride is when I say it's used as a toothpaste. But where do we get this calcium hydroxide? You remember when you said limestone, when you heat, you produce calcium oxide with CO2. So we remained with calcium oxide. This calcium oxide is reacted with water to produce calcium hydroxide. So here, the calcium hydroxide, this calcium hydroxide from the Lem's liquor, so here it is calcium hydroxide. It is taken to the ammonium recovery. So here, ammonium chloride is reacted with calcium chloride. So calcium hydroxide is reacted with ammonium chloride. So here, to produce calcium chloride as a byproduct, and ammonia is taken back here as a reaction. So here we have recycled two things. In this carbonating tower, we recycled water. That is the first thing. We recycled water back. And the second thing, it is ammonia. So here ammonia, we recycle it back by reacting ammonium chloride with calcium hydroxide. So here calcium hydroxide, we obtain calcium chloride. And where did this calcium hydroxide come from? From the calcium oxide we added water. So here we used water and we got ammonia with calcium chloride. So you see how this industrial process is very economical. Yes. So we take it to the we go to the second one, which was here we had remained with this ammonium chloride was the residue. Then we had remained with the filtrate, which is sodium hydrogen carbonate. So this sodium hydrogen carbonate, as we have said, it can be used in the bakery to raise dough. But also this sodium hydrogen carbonate can be heated to a temperature of 300 degrees to obtain sodium carbonate. So this sodium carbonate is the one that I listed the uses, the required process. So here the general reaction for the formula is calcium carbonate here, limestone with sodium chloride here, calcium carbonate, sodium chloride, they react to form sodium carbonate plus calcium chloride, which is the byproduct. These two are the byproduct. So if you see the industrial process, it has several steps, but it's easy to grasp because it doesn't have to, you don't have to go in detail so much about the procedures. They are simple and the reactions are really simple. What you need to grasp here is just ammonico brine or ammonia with brine, which is concentrated sodium chloride with ammonia. It has less, it does not have a general chemical formula, so it is separated. And in this carbonating tower, you add CO2, and that CO2, you know where it comes from. Then after the CO2, the filtration. So here in this chamber, this is where the engine of the reaction is, and this is where the reaction takes place. So this carbonating tower, or we can say carbonating chamber, is where all the reactions, the general reaction takes place. Then after that, you must remember it is always filtration, because one is a solid and the other one is a liquid. So after filtration, you will access the ammonium chloride and sodium hydrogen carbonate. So sodium hydrogen carbonate, this one is the one used to raise dough in baking. This one is the baking powder. It is in the baking powder. So here, this sodium hydrogen carbonate can be heated to a temperature of 300 degrees Celsius to obtain sodium carbonate. And here, the interesting thing is that when you heat this sodium hydrogen carbonate, you'll get sodium carbonate plus water. And also this water, it is recycled back to the carbonating tower. You see how the things are recycled there? So it is easy to get how things are recycled, because here the remaining water is recycled back and it will be used again in the procedure. And calcium oxide is also recycled from here, because here the byproduct from lime kiln was calcium oxide. This calcium oxide water is added to the calcium oxide. They can also decide to use this water here in the calcium oxide to produce calcium hydroxide. So this calcium hydroxide is taken to the ammonia recovery. So ammonia recovery reacted to produce ammonia, and it's that simple. All you need to get is to analyze these reactions that takes place, or we can go one by one and analyze it. So calcium carbonate here with calcium oxide, and this one we have said that one is an experiment in the lime kiln here. Then carbon reacted with oxygen to produce CO2. You see, in this reaction, the manufacturer can go the other way, or can take another way, or can take an alternative way of producing CO2 by reacting carbon with excess oxygen to produce CO2. So here, this CO2, it is taken to the carbonating tower. But you know, here it depends with how the industrialists want to become more economical to the procedures. Because here, when you use calcium carbonate limestone heating, then you will get the two raw materials which are most important. But here, the industrialist can decide to use carbon plus oxygen to get CO2 and use it here. Then he will look for calcium, then mix with calcium oxide, then he mix with water to produce calcium hydroxide, which he will use in the ammonium recovery. Then that one is sorted. We go to the second one, with this calcium oxide is reacted with water, produce calcium hydroxide. So calcium oxide from this lime kiln is reacted with water in the lime slaker, produce calcium hydroxide. So here, this calcium hydroxide, it is the one that is taken to the ammonia recovery, and it is called ammonia recovery because here we get ammonium chloride. Ammonium chloride is reacted with calcium hydroxide to get ammonia, which this ammonia is used in that experiment. And then ammonia is reacted with water to produce ammonium hydroxide. So this is the experiment of here, because I told you ammonia has a higher affinity of water than sodium chloride. So ammonia dissolves in water more faster than sodium chloride. So ammonia will dissolve in water to get ammonium hydroxide. So that ammonium hydroxide then reacted with the CO2 to get ammonium hydrogen carbonate. So here ammonium carbonate is reacted with sodium chloride with CO2. So sodium chloride will react here to get sodium hydrogen carbonate plus ammonium chloride, because here, as you have said here, it is this one will react with sodium chloride, produce sodium hydrogen carbonate plus sodium hydrogen carbonate plus the ammonium chloride. So this experiment, this reaction takes place in the carbonating tower, because the first thing here, ammonia will react with water, produce ammonium hydroxide because it has a high affinity, as I repeat. And this one, sodium chloride, will react with ammonium carbonate to get the ammonium chloride. Then from that ammonium chloride, then it's reacted with calcium hydroxide. Then that is the second thing. The third reaction is here, where heat is applied. Heat is applied at a temperature of 300 degrees Celsius, produce sodium carbonate. So in this reaction, there is no catalyst used. There's no catalyst used, and is one of the simplest and economical, as I've said, and it is very simple to craft. So you have to just master the raw materials, the recycled materials, and the procedures, and the chemical chemical formulas for the reactions that take place in the Solvay process. And that's from that one, it means you are good to go. You're good to handle any Solvay process, and it is very simple. Yeah, it is very simple to handle it. So thank you guys for being with me, for listening my lecture. I hope you have understood. If it's not understood, please go to the comment section and you tell me what you have not understood. Then I will try to explain it in the next video. If you have a question, you let me know in the next video so that I can really improve on my lecturing and on my teaching on the processes and others. So we'll be next time. Thank you.